The wreck waited in the hush of the Russian tree line, its silhouette rising from the soil like the forgotten ruin of a fortress. When the U.S. tankers first approached it, they did so with the hesitation of men who sensed that the quiet around them was not natural. The burned smell of cordite lingered in the air, faint but unmistakable, as if the earth itself still remembered the violence that had passed through only hours before. Up close, the shape became even more imposing. The steel hull, blackened by fire yet unbroken, seemed less a vehicle than a statement, an armored monolith stranded in an open field. Sunlight slid across its plates without revealing weakness. The men, accustomed to the familiar geometry of German armor, found themselves staring instead at something that felt heavier, more deliberate, as though it had been engineered for a different kind of war entirely. Heat scars streaked the casemate. Impact marks clustered in dull constellations across the armor, but none of the usual signs of defeat were present. There were no seams split open by high-velocity rounds, no ragged holes punched through by AP shells. A lieutenant traced his hand along the flank, searching for the evidence that should have told the story. Instead, he found only the marks of weapons that had failed. He circled the machine slowly, and the men followed, their boots whispering through the grass. Someone finally said what the others had only been thinking. This was no tank. This was one of the German Ferdinand heavy tank destroyers, machines Allied intelligence had spoken of only in fragments, machines rumored to kill at distances where most crews saw nothing but haze. Peering inside, they found an interior dominated by its immense 88 gun. Everything else seemed secondary. Armor, ammunition, engine, all arranged around a single purpose. Yet amid the machinery an absence lingered, no hull machine gun, no provision for close defense. A weapon built to annihilate at long range, but nearly helpless when the enemy drew near. None of them yet understood how that contradiction would shape the battles still to come. But another wreck, deeper in the forest, was already waiting to explain it. They began with the front glacis, the place where most armored stories announced their ending. But here, the steel told a different tale. The plate rose at a shallow angle, thick enough that even scorched and soot-streaked it carried a quiet authority. The tankers traced the faint impressions left by their own weapons and understood with a kind of reluctant respect why those rounds had barely left a mark. This was armor meant to defeat expectation, an engineered rebuttal to the very idea of vulnerability. Just above it, the long barrel of the 88 Impact 43-2 remained fixed in its mount, a weapon once capable of killing at distances that reduced battlefields to abstractions. Fire had warped the steel slightly, bowing it in a subtle arc, yet even damaged, it exuded a sense of purpose. The gun's reputation had reached the Americans long before they reached this wreck. But standing beneath it, seeing the scale and precision of its construction, they understood why German crews had believed they could shape the geometry of combat from kilometers away. Inside the casemate, the truth became clearer still. Every component, racks of ammunition, reinforced frames, the massive breech, spoke to a machine optimized not for maneuver, but for the cold arithmetic of long-range fire. It was a philosophy rendered in steel: deliver destruction from afar, avoid the chaos of proximity, and let distance serve as both weapon and shield. Mobility, vision, and flexibility had all been sacrificed to make room for this single, overwhelming purpose. A sergeant studied the narrow viewports and shook his head. In a close assault, he observed, the crew would have seen little more than shadows. Another man pointed to the blank plates along the hull, surprised to find no defensive machine gun, not even a simple pistol port, a rarity in any armored vehicle and almost unthinkable in one meant to operate at the front. The realization settled over them gradually. This machine had not died because its armor failed or because its gun was outmatched. It died because the battle had come too near, collapsing the distance on which it depended. And deeper in the wreck-strewn fields of Orel, they would soon discover how that flaw reshaped an entire offensive. The more they studied the wreck, the more a quiet clarity settled over the American tankers. What they had first taken for an exotic curiosity now revealed itself as the logical result of a single design decision. The massive 88 gun, so formidable at range, had dictated every compromise that followed. Armor, visibility, mobility, each had been shaped not by balance, but by devotion to the weapon that defined the Ferdinand's purpose. It was as if the entire vehicle existed only to serve that gun, and everything unrelated to its long reach had been allowed to fall away. They began comparing it to their own machines, and the differences carried an almost human weight. In a Sherman, no crew would venture forward without a bow gunner ready to meet the threats that lived at close quarters. Here, the absence of such protection felt less like a mistake and more like a faith, an assumption that the battlefield would honor theory, that distance would always be preserved, that no enemy would dare approach a weapon of such reach. The Americans knew better. Combat, in their experience, rarely respected the intentions of engineers. Even the optics reinforced the message. The lenses were fine instruments, precise and well-grounded, but their design spoke only to long-distance fire. These were eyes meant to pierce haze and horizon, not to detect an infantry squad weaving through smoke 30 meters away. In the dark interior, the tankers imagined a crew trapped inside, fighting with sightlines that dwindled the closer danger crept. Outside, beneath the churned soil, they found the spent casings of German rifles. The pattern suggested a brief, desperate defense, infantrymen firing from cover to buy time for a vehicle that could not protect itself. It was a small detail, yet it reframed the entire scene. Engineers had built a fortress, but they had not given it guards. They had trusted that the machine's purpose would shield it from the disorder of real battle. In that moment, the Ferdinand became more than wreckage in a field. It became a symbol of misplaced belief in perfect conditions, a reminder that war punishes certainty. And beyond Orel's tree line, more ruins waited to show where that belief had finally broken. By 1942, German armored doctrine stood at a crossroads, shaped as much by ambition as by necessity. The Eastern Front had revealed a harsh arithmetic of firepower and protection, and the German High Command sought a new generation of heavy tanks that could restore the strategic initiative. What followed was not a unified industrial effort, but a contest. Two competing visions, two competing egos, each vying to define the future of armored warfare. Ferdinand Porsche, long accustomed to the favor of the regime, presented a design that reflected his characteristic boldness. His prototype promised innovation on a grand scale: electric transmissions, advanced suspensions, and a silhouette built around thick armor and heavy armament. Henschel's rival design, more conventional but robust, emphasized reliability and battlefield pragmatism. Both companies prepared full-scale prototypes for Hitler's inspection, each hoping to secure the contract for Germany's next heavy tank. When the decision finally came, Porsche's team found themselves on the losing side of industrial history. Technical concerns, chief among them the untested and temperamental electric drive, led to the rejection of his design. But by then, production momentum had already carried Porsche's project far beyond the drawing board. 90 chassis had been completed, each an immense steel foundation awaiting a role they no longer had. Scrapping them would have wasted valuable material and labor, commodities Germany could no longer afford to discard. Instead, the Army Weapons Office intervened with a solution that blended opportunity with expedience: convert the chassis into heavy tank destroyers. The decision reflected a confidence that engineering could compensate for strategic strain, a belief that overwhelming power at long range could resolve the war's widening imbalance. In the design that followed, this philosophy became unmistakable. Engineers mounted the formidable 88 Impact 43 onto the chassis, creating a weapon capable of destroying Soviet armor at distances where return fire was little more than conjecture. Everything about the vehicle reinforced this emphasis on reach: massive frontal armor, a fixed casemate to support the gun's weight, and internal arrangements that prioritized ammunition storage and firing stability over crew flexibility. But by choosing such singular focus, the designers also chose what to exclude. No bow machine gun, no defensive ports, limited visibility. These omissions were not oversights. They were the logical extensions of a belief system. If the vehicle could kill at 2 kilometers, it was reasoned, then threats at 50 meters could be dismissed as improbable or irrelevant. The machine would operate behind infantry screens. The enemy would be kept at distance. The battlefield, in theory, would behave as the engineers expected it to. Yet beneath this confidence lay an absence of real-world validation. The lessons of the Eastern Front, its chaos, its shifting lines, its brutal intimacy, were muted beneath layers of technical optimism. In 1942, Germany placed its faith in engineering excess, trusting that mass and caliber could dictate outcomes. And as the Ferdinand took shape, no one yet imagined how ruthlessly the battlefield would test that belief. Far the East, Soviet tacticians were already developing methods that would bring those assumptions into doubt. The Ferdinand took shape in steel halls that echoed with the rhythm of welding torches and the steady din of armored ambition. Each plate, lifted into place by cranes straining under the weight, reflected a philosophy as much as a design requirement. The frontal armor alone reached thicknesses unprecedented in any German vehicle to that point. 200 millimeters of steel layered into a barrier that no Allied gun in 1943 could reliably pierce. To the engineers, this was not excess. It was certainty made visible, the belief that survival could be forged through sheer density. At the center of this evolving structure stood the gun that had inspired the machine's very existence. The Pak 43-2, derived from the fearsome 88, promised lethality at ranges where most engagements were theoretical on a map. Capable of defeating any Allied tank with room to spare, it became the heart around which all other considerations revolved. The Ferdinand was not an armored vehicle into which a gun was placed. It was a gun for which an armored sanctuary had been constructed, each joint and weld reinforcing its purpose. The casemate that housed it resembled more a fortification than a vehicle compartment. Its dimensions were dictated not by crew comfort, nor by tactical flexibility, but by the need to stabilize a weapon of exceptional length and recoil. The decision carried consequences. Interior movement became restricted. Gun traverse remained narrow. Defensive positions for supporting weapons were dismissed as unnecessary distractions. The design embraced the isolation of long-range combat, assuming that distance would be its shield, and that the chaos of close fighting could be designed out of existence. But as the Ferdinand grew, so did its weight. Approaching 65 tons, it demanded roads that could bear its mass and bridges that often could not. Fuel consumption rose accordingly. Tracks and drivetrains were pushed to their mechanical limits. Underneath the armor, the dual electric motor drive system, an ambitious feature inherited from Porsche's original prototype, introduced its own vulnerabilities. The system required careful maintenance, steady voltage, and wiring that did not always enjoy the same protection as the armor it supported. Should damage sever the electrical pathways, mobility could vanish in an instant. Yet none of these compromises shook the confidence of the design team. They believed that the sum of the vehicle's strengths would eclipse its vulnerabilities. A machine that could not be penetrated from the front, armed with a gun that could destroy beyond the horizon, needed no provision for close defense. It simply had to operate as planned. The battlefield, in their minds, was a place where technological equations held firm and where outcomes could be shaped by engineering logic alone. In crafting the Ferdinand, they built more than a tank destroyer. They built an armored cathedral, monumental, focused, and doctrinal in its faith. What they could not see from the drafting tables was how swiftly the Eastern Front would challenge the assumptions on which it stood. And at Kursk, those assumptions would face their first trial by fire. As spring turned towards summer in 1943, the German High Command placed its hopes for a renewed offensive on a single point of the Eastern Front, a salient the Soviets held around the city of Kursk. Operation Citadel, conceived as a double envelopment, aimed to cut off the bulge and restore the initiative lost at Stalingrad. Into this plan, with its maps, arrows, and assumptions of precision, the newly formed Ferdinand units were woven. The 653rd and 654th Heavy Tank Destroyer Battalions were to serve as armored scalpels, carving open the Soviet defenses with the clean efficiency the designers believed their machines could guarantee. For German planners, the presence of the Ferdinand became more than a tactical asset. It became a promise. Its armor and gun, measured in millimeters and meters per second, seemed to offer a solution grounded in mathematics. A vehicle that could not be penetrated from the front and could kill at 2 kilometers would, in theory, make breakthrough not only possible but inevitable. The battlefield was imagined as a diagram awaiting confirmation, its variables neatly contained within the specifications of the new tank destroyer. Crews assigned to the battalions trained diligently, but their preparation reflected the same assumptions that had shaped the machine itself. They practiced gunnery at long range. They drilled on mechanical maintenance. What they did not receive, what doctrine did not require, was meaningful instruction in close defense or coordination with infantry screens. Their role, as defined on paper, did not include fighting at distances measured in meters. If enemy troops reached the casemate, something had already gone wrong in the broader PL. And, beneath these expectations, logistical officers faced a more grounded reality. Transporting 65-ton machines to the front demanded reinforced railcars, strengthened bridges, and roads that could endure repeated stress. Fuel allocations had to be increased, spare parts stockpiled, and maintenance crews trained to handle electrical systems unfamiliar to most field workshops. Every kilometer forward required effort disproportionate to the movement of conventional armor. Yet the operational plan treated these obstacles as temporary inconveniences, details to be managed, not warnings to be heeded. On the other side of the salient, Soviet commanders watched the buildup with measured understanding. Reconnaissance flights noted the arrival of heavy German vehicles. Radio intercepts suggested a timetable. In response, they thickened minefields, deepened anti-tank ditches, and positioned artillery with overlapping fields of fire. What emerged across the defensive belt was not a thin screen, but a layered system designed to absorb, slow, and bleed any assault, regardless of the machines leading it. German planners viewed these defenses through the lens of technical superiority. They believed the Ferdinand's armor would shrug off mines, that its gun would silence enemy strongpoints before they could respond. The idea that doctrine might be challenged by terrain, or that armored mass could become a liability, found little room in the optimism of the offensive's early days. Confidence hardened into expectation, and expectation into a quiet arrogance, the belief that engineering could overrule the uncertainties of war. Thus the stage for Kursk was set, an assault built on theory advancing toward a defense built on experience. And as the Ferdinands rolled toward the line of departure, their crews had yet to learn how swiftly theory dissolves when the first obstacles appear. Dawn on 5 July 1943 rose behind drifting curtains of smoke, the light weak and fractured, as though even the sun hesitated to reveal the scale of what was about to begin. Along the northern face of the Kursk salient, the Ferdinand battalions took their places in the assault formations of the Ninth Army. Engines hummed beneath armored decks, vibrating through the soil in a low, metallic tremor. When the signal came, the great machines moved forward, not with the speed of lighter armor, but with the measured certainty of something built to endure. Ahead lay the densest defensive belt the Germans had yet faced, and behind them stretched the confidence of an army convinced that engineering superiority could rewrite the rules of battle. The opening Soviet artillery barrage struck with a violence that shook dust from the casemate roofs, bursts erupting with such force that even steel seemed to flinch. Yet as the first shells landed, the Ferdinand crews felt an unexpected reassurance. The rounds detonated harmlessly against the frontal plates, leaving scorch marks and shallow impacts but no breaches. Here, in the crucible of real combat, the German assumptions found their proof. The thick armor, calibrated and tested to defeat high-velocity threats, now absorbed the punishment of Soviet guns whose ranges fell short of exploitation. It was a moment in which numbers translated into survival. As the barrage tapered, the Ferdinands began to fire. Their long barrels reached over the rolling ground like instruments of geometric certainty. Each shot, guided by optics designed for measured distance, found Soviet armor well before Soviet gunners could return effective fire. T-34s attempting to shift positions were struck at ranges approaching 2 kilometers, their silhouettes dissolving into smoke and dust. In the span of hours, the Ferdinand units accounted for dozens of enemy tanks, validating the rationale behind their creation. Within the casemates, the crews worked with calm precision, their confidence strengthened by every distant flash that marked another destroyed target. But the battlefield had its own dimensions, ones that no range, table, or armor thickness could fully predict. The minefields laid across the approaches, meticulously arranged and concealed, did not discriminate between technological marvels and ordinary vehicles. Several Ferdinands, advancing in staggered lines, found their progress halted abruptly as explosions tore through track assemblies or shattered suspension elements. These blasts did not penetrate the armor, but they achieved something more consequential. They stripped the vehicles of mobility. A 65-ton machine immobilized in a fire-swept zone became an island, visible, vulnerable, and suddenly dependent on events it could no longer control. The crews inside those disabled vehicles waited for recovery teams that were slow to arrive under the weight of enemy fire. With no defensive machine gun and only personal weapons, they could observe but not repel the movement around them. Soviet infantry, scattered by the initial artillery. Rye exchanges regrouped quickly. Small units crawled forward, using folds in the terrain, craters, and smoke for concealment. Their task was simple in description and brutal in practice. Eliminate immobilized armor before it could be repaired. Through narrow vision slits, German gunners saw figures dart between patches of earth, closing distances that the vehicle's design philosophy had dismissed as improbable. The Ferdinand's imposing armor meant little now. Angle and thickness could not prevent a sapper from reaching the rear deck or side plates. Grenades clattered against steel, their detonations sending shudders through the hull. The first losses in the battalions did not come from enemy tanks or direct-fire guns, but from soldiers who had crossed the gulf between theory and reality on foot. Outside, Soviet sappers worked with a grim efficiency born from months of preparation. They knew where the blind spots were. They knew that the casemate gun could not pivot to engage them. They knew that a machine built for long-range duels became nearly helpless once immobilized. What German engineers had regarded as a negligible risk, Soviet infantry now exploited with deliberate skill. The crews inside did what they could, fought fires, sealed compartments, and sent urgent calls for support. But the design that protected them at distance now betrayed them at arm's length. As smoke thickened across the advancing front, the Ferdinands continued to rack up long-range victories. Yet scattered among the successes lay the first wrecks, hulks not pierced by shells, but destroyed by proximity. The contrast between triumph and loss grew sharper with each kilometer gained. And as the German spearhead pushed deeper, it had yet to encounter the strongest Soviet defenses waiting farther ahead. The northern face of the Kursk salient was not the open terrain imagined in the planning halls of Berlin. Instead, the ground folded into uneven fields, narrow ravines, and thickets of scrub that fractured the battlefield into a series of confined corridors. As the German spearhead pressed forward, the Ferdinands, designed for long-range duels over unobstructed distances, found themselves navigating terrain that demanded agility they did not possess. Each kilometer gained tightened their maneuvering space, drawing them into landscapes where their greatest strengths were muted by circumstance. Infantry support, essential for protecting the vulnerable flanks of heavy armor, often lagged behind the pace of the advance. The Ferdinand battalions moved cautiously but continuously, pushing through minefields and artillery zones where foot soldiers struggled to follow. Dust, smoke, and the constant threat of counterfire scattered the supporting units into fragmented groups. What had been promised in planning, a screened attack with armor and infantry advancing in layered formation, dissolved under the pressures of real combat. And as the Ferdinands edged forward alone, the weaknesses that their designers had considered unlikely began to surface with increasing clarity. The Soviets recognized these gaps with practiced eyes. Their local commanders, trained to probe for openings rather than confront armored mass directly, launched counterattacks against the spaces between German formations. Small assault groups slipped through the seams left by the overstretched infantry. Their movement was not grand or sweeping. It was incremental, opportunistic, and precise. A ridge held long enough for German armor to pass became the staging point for an attack on the isolated vehicle, now sitting, exposed a few hundred meters ahead. Inside the Ferdinands, crews found themselves forced into engagements their vehicle had never been built to fight. The 88 gun, a masterpiece of long-range lethality, became a blunt instrument at close quarters. Targets appeared not as distant silhouettes, but as fleeting shapes darting between mounds of earth and brush. To fire at such range required the entire casemate to rotate, a process both slow and imprecise under battlefield pressure. Every shot landed with devastating force, but the rhythm of combat no longer favored deliberate accuracy. The gun's dominance at 2 kilometers became an awkward liability at 20 meters. When Soviet infantry closed in, the weight of the Ferdinand offered no protection beyond the armor itself. The vehicle lacked the tools to contest proximity. Crews attempted to reverse out of danger, but the heavy machine responded slowly. Others called desperately for supporting fire or smoke to obscure the enemy's approach. In several encounters, the threat arrived faster than help could be summoned. With no bow machine gun and no firing ports, the only options remaining were retreat or exposure. Some crews resorted to actions that underscored the vehicle's design limitations with stark clarity. Men opened hatches just enough to fire pistols or rifles at attackers darting across the engine deck. Others tried to use flare guns to deter soldiers attempting to climb aboard. It was not training but instinct that guided these moments, an improvised defense in a machine that offered none. And each act carried immense risk, for the open hatch invited grenades and small arms fire with equal ease. In the smoke and tumult, the Ferdinand's engineered brilliance, its armor, its gun, its carefully arranged interior, lost their meaning. Battles that unfolded at ranges measured in meters made technical precision irrelevant. The controlled experiments envisioned by its designers collapsed into the unpredictability of mud, movement, and men fighting at arm's length. The crews, skilled and disciplined, now labored inside a machine that no longer matched the world outside its steel walls. As the day wore on, the strain of close-quarters combat left its mark across the battalions. Vehicles that had dominated the early hours with long-range efficiency now bore scars from grenades, mines, and rifle fire. And each new engagement revealed not simply the flaws of a design, but the widening distance between German expectations and the realities shaping the front. Ahead, the Soviet defenses thickened still further, layers of resistance that would test not only the machines, but the doctrine behind them. As the Ferdinands pressed deeper into the Soviet defensive belt, a different kind of struggle emerged, one not announced by gunfire or ambush, but by the quiet, insistent limits of machinery pushed beyond its comfort. Beneath each armored deck sat the electric drive system inherited from Porsche's abandoned heavy tank design. On paper, it offered smooth torque and simplified control. On the battlefield, under summer heat and constant strain, it revealed a fragility the engineers had never intended to test. Temperatures climbed. Wiring insulation softened. Motors demanded rest in a battle that offered none. Each halt to cool the system eroded momentum, turning the pace of the offensive into a negotiation with physics. Fuel, too, became a problem measured in kilometers and anxiety. The Ferdinand, heavy and inefficient, consumed more than the supply lines could easily deliver. Convoys already stretched thin by the demands of Operation Citadel now had to prioritize the needs of vehicles that burned fuel at a rate unmatched by any other German armored unit. Drivers watched gauges with a tension equal to that felt during incoming fire. A stalled machine could be repaired, an empty one often could not be recovered. The calculus of logistics began to shape the battlefield as decisively as any Soviet counterattack. Maintenance crews labored with a persistence that bordered on resolve. They worked in improvised workshops behind the lines, scavenging usable components from damaged vehicles, stripping wiring, reconfiguring motors, and reinforcing vulnerable electrical casings with whatever materials were at hand. Their repairs were not elegant, but they were necessary. Each Ferdinand returned to the front represented a victory of human ingenuity over the limitations of its own design. Yet every hour spent in repair carried its own cost. The battalions operated at reduced strength, and those still in the field bore increased pressure to perform. Recognizing the scale of the unfolding challenges, German command revised its tactics. No longer would the Ferdinands advance as independent armored wedges. They were now to operate with dedicated infantry escorts assigned specifically to protect them from close assault. It was a concession to reality, an acknowledgement that even a fortress on tracks required guardians. But implementing this adjustment proved difficult. The terrain scattered units, artillery disrupted coordination, and exhausted infantry could not always maintain the pace or protection required. The gap between doctrine and execution widened with each passing day. Minefields remained the constant threat threading through every operation. Even after tactical adjustments, explosions continued to strike the vulnerable running gear, halting vehicles that otherwise remained fully combat-capable. Ambush teams, trained to exploit any moment of immobility, converged on these stalled machines with unwavering discipline. Anti-tank rifles chipped away at external fittings. Grenades hunted for openings in armor that had no business being tested at such range. The Ferdinands endured, but the cumulative damage grew heavier than their steel. In response, crews began modifying their vehicles in ways that reflected the frontline intelligence absent from the design stage. Steel mesh screens were affixed around air intakes to deter grenades. Spare track links were bolted to vulnerable surfaces. Some crews mounted captured machine guns atop hatches, creating improvised positions from which to repel infantry attacks. These adaptations were born from necessity, not doctrine. They represented the lived experience of combat pressing against the orderly world of engineering. With every day of the operation, the gap between concept and reality revealed itself more starkly. The Ferdinand remained formidable at long range. Its guns still delivered fearsome results. But the battlefield asked different questions now, questions about mobility, endurance, and survival in environments that refused to obey design logic. The frontline experience spoke plainly. The machine was powerful but incomplete. Its creators had imagined an ideal battlefield. Kursk offered them the real one, and beyond the next ridge, the demands of that battlefield were about to intensify even further. By the second week of July, the tempo of Operation Citadel had shifted in ways the planners had not foreseen. The early optimism, fueled by long-range victories and the apparent resilience of German armor, began to fade beneath the weight of deeper, more intricate Soviet defenses. Each kilometer gained revealed yet another belt of trenches, minefields, and concealed strongpoints, arranged not as isolated obstacles, but as a system designed to absorb, slow, and ultimately break an advancing force. The Ferdinand battalions, already carrying the scars of the first days of combat, now found themselves confronting not the final line of resistance, but merely the next one. Momentum, once the defining element of the German assault, began to slip away. Artillery fire intensified, no longer scattered but coordinated, falling with unsettling accuracy onto staging points and routes of advance. The infantry units intended to screen the Ferdinand struggled to maintain formation under this pressure. Their losses grew, their spacing widened, and the coordinated rhythm required for combined arms warfare faltered. Without this protective layer, the heavy tank destroyers moved forward more cautiously, their pace dictated not by tactical intent, but by survival. Terrain and mines had already slowed them, but now these factors combined with the deepening Soviet defense to create a chain of vulnerabilities. Ravines channeled movement. Marshy ground consumed time and traction. Mines continued to find their targets, disabling running gear and immobilizing vehicles that would then linger under hostile observation. Even when damage was minor, the sheer weight of the Ferdinand made recovery efforts painfully slow. Each stranded vehicle became a beacon for enemy gunners and infantry teams, who needed no invitation to close in. Soviet tank brigades, held in reserve for precisely this moment, began their counterattacks. They did not engage the Ferdinands directly at first. They attacked the German infantry instead. T-34s advanced in swift, coordinated groups, firing into German positions, forcing the infantry to retreat or scatter. In doing so, they peeled away the protective screen around the heavy tank destroyers, isolating them in pockets of smoke and fire. What engineering had built as an unassailable long-range predator now stood exposed in a battlefield fluid enough to flow around it. Inside the casemates, crews felt the change as a tightening of the world. Their radio traffic grew urgent, infantry retreating, artillery shifting, enemy armor bypassing their position. Without mobility, the Ferdinand's strengths mattered little. Crews attempted to reorient their guns toward approaching Soviet forces, but the narrow traverse made tracking fast-moving targets difficult. Some tried to reverse out of encirclement, yet the ground or damaged tracks denied them. When Soviet infantry arrived, grenades and incendiaries followed. A vehicle designed to withstand the guns of an entire front collapsed under the assault of determined soldiers only meters from its hull. One by one, the Ferdinands that could not be moved were abandoned. Crews disabled their guns, set charges, or destroyed sensitive equipment before withdrawing under cover of what remained of the infantry. The hulks left behind, scarred, burned, or simply silent, stood as markers of an offensive losing coherence. Their thick armor had endured what it was meant to endure. It was the assumptions around them that had failed. As these reports filtered back through command channels, the aura that had surrounded the Ferdinand began to erode. Engineers and officers who had once spoken confidently about its invulnerability now faced accounts of breakdowns, immobilizations, and close-range kills. The weapon that promised to define a new era of armored warfare had instead revealed the cost of designing for an idealized battlefield. Its strengths were undeniable, but so were the conditions under which those strengths became irrelevant. Across the northern sector, the strategic picture clarified with grim certainty. The German advance, deprived of momentum and stretched by attrition, no longer threatened to break through. Soviet counterattacks gained force, exploiting every slowed unit and compromised corridor. What had begun as a carefully shaped offensive now buckled under the compounded realities of Rain, resistance, and doctrine unprepared for adaptation. And as the northern pincer faltered, the wider operation faced a reckoning that no engineering achievement could postpone. As the northern offensive unraveled, the German high command confronted an uncomfortable truth. The Ferdinand's growing list of losses bore little resemblance to conventional armored warfare. Reports flowed in from battalion headquarters, vehicles destroyed, vehicles abandoned, vehicles immobilized and later overrun. Yet in these same documents, a pattern emerged with stark consistency. Very few of the heavy tank destroyers had been pierced from the front. The armor had held exactly as intended. The failures lay elsewhere, in the margins of design and doctrine, in the spaces where theory had overridden experience. Field reports highlighted the same flaw again and again. The absence of machine guns, once dismissed as a calculated exclusion, now appeared as a recurring cause of defeat. Platoon leaders described moments when the long-range gun was meaningless, when silhouettes emerged from the haze at distances too close for a weapon built for precision across open fields. Without a way to sweep trenches or clear advancing infantry, the Ferdinands became static targets, formidable only at ranges the enemy increasingly refused to present. What had been a philosophical choice in design now carried a human cost measured in entire crews lost inside sealed casemates. For the men who operated the vehicles, the psychological burden grew heavier than the steel around them. In combat, the casemate felt like both refuge and trap. Gunners and loaders trained for distant duels found themselves listening for footsteps on the hull, sounds that armor could not stop. Survivors later recalled the dread that seeped into those moments. The muffled thuds of grenades, the scrape of tools against engine grills, the hiss of smoke filtering through ventilation. They could see shapes moving outside, sometimes only meters away, and yet they could do nothing. The weight of immobility, more than the enemy's weapons, sapped their resolve. Several accounts captured the same scene with haunting similarity. Smoke from detonations drifted across the battlefield, reducing visibility to a shifting blur. Out of it, Soviet sappers appeared, small figures moving low and fast, each carrying explosives shaped for a purpose the Ferdinand could not counter. Crews inside watched through narrow optics or cracks in damaged panels, powerless as the attackers advanced. Some shouted warnings over radios, others braced for the blast they knew was coming. In those moments, the gulf between technological ambition and battlefield necessity closed with brutal clarity. Back in Germany, engineers and officials defended the original design philosophy with measured confidence. They argued that the Ferdinand had been conceived for a specific role, long-range destruction in open terrain. Given such conditions, its performance had been exemplary. They pointed to the numbers, the dozens of Soviet tanks destroyed at the opening of Citadel, and insisted that the machine's concept was sound. If failures occurred, they contended, they were the result of tactical misuse or inadequate coordination, not flawed engineering. Technology, they believed, remained the decisive element in warfare. Adaptability, in their view, was secondary. But at the front, this reasoning rang hollow. The distance between factory theory and battlefield reality no longer required debate. It was inscribed across the wreckage scattered along the northern salient. Vehicles designed for idealized conditions had been thrust into an environment that shifted by the minute, where smoke, mud, mines, and infantry shaped outcomes as decisively as caliber and armor thickness. The design had assumed control over distance. The battlefield had taken that distance away. When the fighting at Kursk finally ended, the ledger balanced in a way that no engineer had intended. Of the 90 Ferdinands deployed, only a fraction remained operational. Some had been destroyed outright, others had been disabled and abandoned in terrain too dangerous to recover. Many had simply succumbed to the slow culmination of mechanical strain and tactical inflexibility. What survived was not a legacy of invincibility, but a lesson, one written in exhaustive detail by the crews who had carried their design into the crucible of combat. And yet, even as the northern offensive fell silent, the war was not finished with the Ferdinand. There were still attempts to salvage its promise, still efforts to reshape the machine into something the battlefield could support. The next chapter would not erase the cost of its philosophy, but it would try, one final time, to redeem its potential. By late 1943, the Ferdinand battalions no longer resembled the formidable spearheads that had rolled toward Kursk only months earlier. The surviving vehicles, scarred, overworked, and carrying the weight of a failed offensive, were withdrawn from the front lines. Their retreat was not merely a tactical necessity. It was an admission that the battlefield had exposed truths no amount of armor could conceal. When the battered machines arrived at repair depots deep inside occupied territory, engineers found themselves confronting not just damaged vehicles, but the consequences of a design philosophy tested to its breaking point. In these workshops, far from the smoke and confusion of the Eastern Front, the process of reinvention began. Engineers examined each hull, studying where grenades had lodged, where sappers had climbed, where mines had sheared away track assemblies. The reports from Kursk were laid out alongside these observations, and patterns emerged with unsettling clarity. Every loss tied to close assault, every immobilization that ended in abandonment, every psychological strain described by returning crews pointed to the same conclusion. The Ferdinand had been crafted for a form of warfare that no longer existed. The first major addition was a bow-mounted machine gun, an element whose absence had defined the vehicle's vulnerability. A newly designed armored housing was welded into the glacis plate, giving the driver and radio operator a tool to contest the very threat the original design had dismissed as improbable. It was not a perfect solution, but it was a tangible acknowledgement that even the strongest armor required the smallest means of defense. Next came the commander's cupola. The original Ferdinand offered its crew only limited visibility through periscopes set deep within the casemate. Battlefield reports made clear how often poor vision had contributed to ambushes and delayed reactions. The new cupola, elevated and equipped with vision slits, provided a semblance of situational awareness. No substitute for mobility, but a vital improvement in a machine that had paid dearly for its blindness. Additional refinements followed. Reinforced side skirts were added to deflect anti-tank rifles. Ventilation improvements reduced the risk of smoke accumulation during close engagements. Spare track links were bolted to vulnerable areas. Internal ammunition storage was reorganized for safety. Each change represented a small victory against the constraints of the original design, a deliberate attempt to shape the machine into something more adaptable, more aware of the battlefield it would meet next. With these improvements came a new name. In early 1944, the modified Ferdinands were redesignated Elephant. The choice was symbolic, reflecting both strength and unwieldiness, endurance and inflexibility. It was a name that carried the weight of lessons learned at Kursk, an acknowledgement that brute force alone could not dictate the course of a battle. Where Ferdinand had represented engineering ambition, Elephant suggested a grounded realism born from the hard-earned experience of warfare. The Elephant's next tests came in Italy and the renewed fighting on the Eastern Front. In the rugged Italian terrain, it again demonstrated the remarkable lethality of its long-range gun. Allied tanks caught across open valleys often found themselves destroyed before they could identify the source of fire. At Anzio, Elephants supported defensive positions with a stability that few other armored vehicles could match. Their armor continued to frustrate attempts at direct penetration, forcing opponents to adapt their tactics just as the Soviets had done months earlier. Yet the limitations remained. In Italy's narrow roads and steep inclines, the Elephant struggled with mobility, its immense weight straining engines designed for gentler terrain. Fuel shortages plagued operations, and recovery from mechanical failure often required equipment that was not available. In Eastern Front engagements, minefields and close ambushes once again proved that even improved defenses could not transform the Elephant into a vehicle suited for fluid, fast-changing combat. Crews continued to rely on infantry escorts, and when those escorts faltered, the vulnerability of the heavy tank destroyer resurfaced with familiar consequences. Over time, the Elephant earned a mixed reputation. Crews respected its ability to deliver devastating fire at long range. Enemy tankers feared its accuracy, but commanders and logisticians recognized the burdens that accompanied its strengths. It was a weapon of extremes, remarkable when conditions favored it and costly when they did not. Each deployment became a negotiation between tactical opportunity and operational risk. By the final year of the war, only a handful of Elephants remained. They fought where they could, often in defensive roles, their massive frames now symbols of a different era in German armored doctrine. The lessons drawn from their service, about flexibility, mobility, and the limits of engineering purity, would resonate in post-war military thinking across nations. In the end, the legacy of the Ferdinand and Elephant became neither triumph nor failure, but something more nuanced. They embodied brilliance shaped by theory and constrained by the unforgiving demands of real battlefields. Their story revealed that even the most powerful machines are inseparable from the assumptions of their creators. And as the war moved toward its final, desperate stages, those assumptions would face one last test in battlefields that cared nothing for design intentions, only for survival. When the American tankers pushed through the forests west of Orel in 1944, The war had already shifted far beyond the events that had shaped the wreck before them. Yet as they approached the burned-out Ferdinand lying half-obscured among the trees, they were unknowingly stepping into the final chapter of a story that had begun years earlier in drawing rooms, factories, and design bureaus. What they found in that clearing was not simply a destroyed vehicle, but the physical residue of a long chain of decisions, each made with confidence, each carrying consequences that the steel around them now recorded in mute detail. The closer they stepped, the more the evidence revealed itself. Scorched branches hung low overhead, their bark charred by the heat of the explosion that had torn through the casemate months earlier. The Ferdinand's wiring, once meticulously routed through conduits and panels, now hung in melted strands, fused into brittle shapes that crumbled at a touch. Bearings from the electric drive system lay shattered on the ground, their casings split open by internal pressures no blueprint had ever anticipated. The thick armor, so proudly advertised as impenetrable, bore the discoloration of an internal fire, heat marks radiating outward like the rings of a fallen tree. Yet even in ruin, the massive 88mm gun dominated the scene. Its barrel, twisted slightly by heat, still projected an aura of latent power. One tanker remarked that it looked less destroyed than dormant, as though waiting for a new crew to breathe life into it once more. The breech mechanism, though cracked and immovable, remained impressive in size and workmanship. For the Americans, accustomed to the dimensions of the Sherman's 75 and 76mm guns, the scale of the weapon offered a glimpse into the German commitment to overmatch, to building machines that could not simply compete but overwhelm. But as they surveyed the vehicle, it was the silences, the absences that spoke with even greater clarity. The missing bow machine gun, the lack of any defensive firing ports, the smooth, uninterrupted plane of the hull where a weapon should have been, all of these omissions now formed a narrative in steel. They were not mere design quirks. They were decisions. And in the wreckage, those decisions had consequences that could no longer be softened by doctrine or optimism. The Americans stood around the open hatch, peering into the dark interior. Inside, they saw the remnants of ammunition racks warped by heat, fragments of optic housings, and floor plates coated in soot. What they did not see was any sign of resistance mounted from within. There were no positions from which a crew could have defended itself against infantry. No tool for contesting the space between long-range engagement and helpless proximity. At that moment, the tankers understood, perhaps more clearly than the designers ever had, how a machine could rule at 1,000 yards and yet die at 10. Some of them were engineers by training, or at least mechanically inclined by profession. Kneeling beside the wreck, they sketched diagrams and measurements into notebooks for intelligence officers further behind the lines. They traced the armor thickness. They documented the drive system. They described the firing chamber of the gun and noted the flawed assumptions embedded within the design. For these men, the Ferdinand was no longer just a curiosity. It was a case study, a relic from an enemy who had believed that technology could predict the shape of war. To the Americans, the machine became an artifact of a particular kind of thinking, a belief that perfection on paper could dictate the behavior of a battlefield. The wreck, with its burned wiring and ruptured casemate, offered a humbling counterpoint. Here lay the limits of engineering untempered by adaptability. Here stood the remains of a doctrine that expected conditions to stay ideal, even when war had proven otherwise at every turn. As they walked back toward their own vehicles, the forest absorbed the scene once more. The Ferdinand remained where it had fallen, a monument not to invincibility, but to the fragile bridge between design and reality. And farther ahead, the Americans would soon encounter another wreck, one that revealed a different flaw and a different lesson in the story of German armored ambition. In the years that followed the war, as military historians sifted through battle reports, engineering notes, and the fragments of armored hulksla, FT scattered across Europe, the Ferdinand emerged not simply as a weapon, but as a case study. It was a machine whose story extended beyond its steel, one that revealed the consequences of designing for a world that existed only on paper. What scholars found in its record was not contradiction, but duality, a weapon that achieved brilliance under ideal conditions and fragility the moment those ideals dissolved. Historians often began their analyses with a single observation. The Ferdinand was an instrument of overspecialization. Its creators had envisioned a battlefield where ranges could be controlled, where terrain could be predicted, where the enemy would oblige by presenting itself at distances measured in kilometers. In this imagined environment, the Ferdinand's characteristics made perfect sense. A massive gun, immovable armor, and a philosophy that centered destruction long before the enemy could threaten its position. It was a masterpiece for a battlefield that seldom existed. But the Eastern Front was a place where few plans survived contact with the facts of geography and the adaptability of its combatants. Mud, mines, forests, ravines, smoke, and sudden counterattacks compressed engagements into unpredictable patterns. Even the largest operations, Kursk most of all, unfolded in ways that defied neat lines on a planner's map. In this world, the Ferdinand's narrow specialization became a liability. It excelled when distance was maintained. It suffered when war refused to honor that distance. Thus, the machine became a living illustration of the danger inherent in designing for theory rather than for reality. The long-range gun, built with an almost philosophical devotion to precision, became a monument to misplaced confidence when fired at point-blank range against infantry swarming from the smoke. The armor, so formidable at the front, offered little comfort to crews who could hear sappers moving somewhere outside their line of sight. The absence of a defensive machine gun, a decision grounded in elegant theory, became the source of repeated tactical catastrophes. And yet, to dismiss the Ferdinand as a failure would be to ignore the extraordinary aspects of its service. Its long-range kills at Kursk were unmatched by any armored vehicle of the war. Soviet tank crews learned to fear the weapon even before they encountered it. The machine did undeniably achieve the performance its designers promised when circumstances allowed. But war does not respect such narrow margins. A vehicle that dominates at one range and collapses at another reveals as much about doctrine as it does about engineering. The post-Kursk modifications, the bow machine gun, the commander's cupola, the reconfigured interior, were practical responses to battlefield realities, but they could not change the machine's underlying nature. Even the renamed Elephant, improved and battle-hardened, continued to struggle against the fluidity of modern warfare. Its logistical demands remained heavy. Its maneuverability remained limited. Its vulnerability to determined infantry never vanished entirely. The redesign addressed symptoms, but could not undo the assumptions welded into the original chassis. Ultimately, the Ferdinand's legacy settled into a place that resisted simple categorization. It was neither triumph nor disaster. Instead, it became evidence of a deeper military truth. Strength, when built without flexibility, becomes a form of weakness. A weapon that depends on perfect conditions survives only as long as those conditions endure. And in war, especially on the Eastern Front, conditions shift faster than doctrine can adjust. Historians now point to the Ferdinand as a reminder of the limits of technological certainty. Its story reflects not just what engineers hoped war would be, but what war actually was: chaotic, personal, improvisational, and unforgiving. The machine's greatest achievements and its greatest failures sprang from the same source: a belief that power could dictate reality. And as the final chapter of the Ferdinand story unfolds, that belief faces one last reckoning, carried not in steel, but in the lessons it left behind. The Americans lingered only a few minutes more beside the wreck before turning back toward their own vehicles. Rain from the previous night had softened the ground, and each step pulled at their boots as though the earth itself wished to keep them near the ruin a little longer. Behind them, the Ferdinand remained half buried in the mud, its massive hull sinking slowly into the soil, the final weight of its story settling with it. No one spoke as they walked away. Some machines required no explanation beyond their own remains. What they had witnessed in that clearing clarified both the terror and the failure that had followed the vehicle across the Eastern Front. The stories that had reached Allied lines, accounts of tanks destroyed before they could return fire, of shells glancing off impenetrable armor, suddenly made sense, and yet so did the reports of abandoned hulks, of crews lost without a frontal penetration, of vehicles immolated by explosions from within. The contradiction was not contradiction at all. It was the machine's nature, revealed in full only when seen up close. The Ferdinand had been built to dominate open battlefields with mathematical certainty. It was a weapon shaped around a single premise: that war could be managed from distance, that range could substitute for flexibility, that a powerful gun could simplify every problem posed by an enemy. In open country, under clear skies, with infantry in perfect formation beside it, the machine had indeed commanded the battlefield. Its fire reached farther than any Allied tank could hope to match. At those ranges, it did not duel, it simply decided. But the same weapon designed for perfect circumstances found itself defeated by the one threat its designers dismissed as unlikely. Mines, ravines, and the unpredictable violence of terrain robbed it of movement. Smoke and dust compressed battlefields into narrow spaces. And in those spaces came the figures the Ferdinand could not fight. Infantry crawling through the debris of shattered ground, sapper teams advancing with purpose, soldiers who understood that even the thickest armor could not protect a machine blind at close quarters. What the gun could not reach, they could. For the Americans studying the wreck, the irony was almost architectural. The Ferdinand's steel shell, the very thing meant to guarantee its survival, preserved the arrogance of its conception more clearly than any document. The absence of a machine gun, the narrow sightlines, the rigid casemate, the fragile wiring concealed beneath thick armor, all of it remained intact enough to tell the story. The wreck had become a diagram of misplaced certainty. Every burned plate and twisted bracket recorded a choice made far from the battlefield, each taken in confidence that the battlefield would comply. In its silence, the machine offered a final lesson, one more enduring than its steel. War, indifferent to design and expectation, does not reward purity of concept. It rewards adaptability, awareness, and the capacity to meet threats not yet imagined. The Ferdinand had been strong enough to command attention from every soldier who saw it, but strength alone could not guide it through the shifting realities of modern combat. Its power had been immense. Its assumptions had been greater still. Only when the tankers reached the tree line did one of them look back. The wreck stood exactly as they had found it, immobile, solemn, framed by the forest that had outlasted both sides. The Americans did not yet know how long that steel would remain there, nor how many future soldiers or historians would pause before it, searching for meaning in its ruin. But they understood, at least, what it had proven. They thought it needed only a great gun. In the end, it needed everything else.